Welcome back, everyone. In this video, we're going to talk about high availability or HA and MCLAG configurations using FortiGate and FortiSwitch. So the goal here will be just to be to understand how to build a more resilient design using two FortiGates and two FortiSwitches. We want to remove single points of failure and make sure that if we lose a firewall or a link or even a switch, the network will continue to operate with as little disruption as possible. So we're going to start with the FortiGate slide. We'll talk about HA or high availability, and then we'll move into MCLAG on the FortiSwitch side. After that, we'll tie it all together, and we'll see how these technologies work together to create a redundant design. So if you've heard these terms but never really understand how they fit into a real deployment, this video should make that much more clear to you. So quickly, let's just talk about FortiGate HA. So no matter where a FortiGate is deployed, whether it's acting as your security gateway or an internal segmentation firewall in the cloud, MSSP environment, if critical traffic is passing through that firewall, it can become a single point of failure. And that's really the problem that HA is meant to solve. So outages can happen for many reasons. Some are physical, like a power failure or a link failure, a transceiver failure, bad power supply. Others can be more logical or software related, like a routing issue, resource exhaustion, or kernel panic, something like that. When that happens, this impact can really cause disruption on your networks. You can have downtime, business disruption, you can have frustrated users, and even financial loss, right? Depending on the environment we're talking about. So when we're designing a network, redundancy and resiliency become extremely important. So where does HA or high availability come in, right? So HA essentially allows us to build redundancy at the firewall level. So instead of relying on a single FortiGate, we'll have multiple FortiGates in a cluster. So if one of the firewalls fails, another unit can take over. So in FortiGate world, HA, the units have to be the same model, running the same firmware version, so they can operate properly in the cluster. And this is important because some FortiGate models are very similar, right? So in this case, if we're just talking about two 91Gs, even if you had a 91G and a 90G, the only difference between those two is that one has a hard drive and one doesn't. But at the end of the day, it still needs to be the same, right? So the hardware model needs to match exactly, and the same with the firmware version. Otherwise, the cluster isn't going to form. So also a cluster can support up to 4 devices, but the most common deployment is a pair of firewalls working together. So really the key takeaway here is just that HA is about keeping traffic flowing and reducing downtime whenever some sort of failure occurs on a firewall. So let's just talk about the two different protocols used when we're talking about HA configurations. So that's FGCP and FGSP. So because they can get confusing, they look very similar. So FGCP is called FortiGate Clustering Protocol, and this is the traditional HA mode that you're probably familiar with. So this is what most people refer to when they talk about HA on FortiGates. So in this mode, the FortiGates essentially form a cluster and it behaves like one logical firewall. The members synchronize configuration between each other and they synchronize session information. So if an active unit fails, another unit can take over. So this is really the standard choice when your goal is just straightforward firewall redundancy. On the other hand, we have FGSP, which is FortiGate Session Sync. So this is FortiGate's Session Life Support Protocol, right? That's what the acronym stands for. And really the key here is that it synchronizes sessions between FortiGates without them actually having to be in a cluster together. So with FGSP, the devices remain independent or standalone. They do not operate as a clustered firewall like they do in FGCP. So really the main purpose here is to share session state information so the traffic can survive in a more advanced design. So what makes it useful here is you might have a setup where you have two separate FortiGates, like even separate HA clusters or some sort of asymmetric routing environment, or even a multi-site environment, like if you had like a redundant data center and you want to keep that session information between both firewalls. That's where you would use this. So really, simply put, FGCP is one cluster built for redundancy, and FGSP is independent firewalls sharing their session information. So now we can just talk about the different types of clustering. So we have active passive and active active HA. So active passive is the most common and straightforward. In this setup, one firewall is actively forwarding the traffic, while the second one is just in a standby role, and it's ready to take over if that primary unit were to fail. So this is a design that most people use. It's simple, predictable, it's very easy to troubleshoot, and it gives you clear failover behavior, and it's usually the best fit for most environments. Active-active is a little bit different. So both units in the cluster can participate in processing certain traffic, but the cluster still has a primary unit controlling the overall operation, right? So it's not like two completely independent firewalls, both fully active in the some way that people might assume. So just keep that in mind. So because of that, active-active setups are a bit more specialized. It can be useful in some designs where you want to distribute specific traffic processing or inspection workloads across the multiple members in the cluster, but it also adds complexity into the environment, just so you're aware. Really, the most important thing here is that even if you're using an active-active setup, you still want to size the environment so that one firewall can handle the full traffic and inspection load if the other unit fails. Otherwise, you're losing just the real benefit of having redundancy in the first place. So we can just touch on quick here, do a quick overview of the primary selection in a HA cluster. So this is the default behavior on screen when HA override is not in use, which is the default HA behavior. So when the cluster is deciding what unit in the cluster should become the primary, it follows a specific order, as you can see. So first it's going to look for the number of monitored interfaces. So the unit with the fewest failed interfaces becomes the primary. And when you think about it, this makes the most sense because the cluster wants the healthiest firewall to take the active role. If there's a tie for the amount of interfaces, it will move to the HA uptime. So for that method, it's going to select the unit with the highest HA uptime. If there's still a tie, it's going to look at the configured priority value, and the unit with the highest priority would win. And if there's still no difference after all of that, the final tiebreaker is the serial number. So whatever unit has the highest serial number takes priority. Now, if you had HA override enabled, we can see how that behavior kind of changes. So the cluster still starts by looking at the monitored interfaces. So the unit with the fewest failed interfaces is still preferred because the FortiGate wants the healthiest unit to be the active. But if there's still a tie, what it's going to check now is the priority, and that's the difference here. So when HA override is enabled, the unit with the highest configured priority is preferred before the HA uptime is even considered. So if the priority is also tied, it will then move on to HA uptime. And if there's still no difference after that, it will then move on to the serial number. So really the takeaway here is that the HA override gives you more control of the unit that you want to become primary in the election process. So without HA override, uptime is checked before priority, and with HA override, priority is checked before uptime. And this is useful when you want one specific FortiGate to retake the primary role after a reboot or a failover instead of just leaving the current healthy member in place based on uptime. Now let's talk about MCLAG on the switch side. So MCLAG is multi-chassis link aggregation, and basically the idea is that two physical FortiSwitches will work together so that from the perspective of the downstream devices, it appears as one logical switch. So this is useful when we want redundancy at the switch level and the link level. Instead of just connecting a firewall or a server to one switch and creating a single point of failure, we can spread those links across two switches. So if one switch fails or a link goes down, the connection can stay up through the remaining switch and the remaining links. So we're going to get improved resiliency. We're also going to avoid delays you would normally associate with only relying on spanning tree for recovery. So in the Fortinet documentation for MCLAG, it describes it as grouping two switches so they appear as a single switch on the network, continuing to function even if a switch fails. So this is really helpful when we have connected devices like FortiGate servers or other infrastructure that needs redundant connectivity without having some sort of layer 2 looping problem. So for this FortiSwitch design, you need to have the supported models. So for the environment we're talking about here, This means you need two switches, two FortiSwitches on 200 series or larger. If you have 100 series switches, you cannot do MCLAG. So just keep that in mind. And the documentation also notes that when we're applying this to 200 series or 400 switches, right, basically the takeaway is just to have a higher end switch. So either 200, 300, 400, 500, 600, or the 1000 series and up switches. So just keep that in mind if you're doing this. If not, you can refer to the documentation on the topologies and do a ring or just a different type of topology. I'll link that into the description so you can take a look at that if you don't have the supported hardware. Now we can just look at the example topology here just to kind of put this all together and give you an idea of how this works. So in this diagram, you can see we have a FortiGate HA cluster in the middle. And we have our internal network on the left, and we have the WAN or the internet side on the right side of the diagram. So on the LAN side, we can essentially use a pair of MCLAG switches so that the FortiGates have redundant downstream connectivity. And then it's also worth noting on the WAN side, right? You might be wondering, what is that switch on the WAN side? I thought I just needed on my LAN. But if we want a fully redundant environment, both of our firewalls need to be able to reach the ISP circuits. So if only one firewall is connected to that ISP handoff, then the failover isn't going to work as seamlessly as you want because the secondary firewall might not have access to the internet connection when it actually takes over. So the challenge is that many ISP handoff routers, so whether you're using Verizon, AT&T, Crown Castle, whatever it might be, they usually only give you one usable Ethernet port to connect to your router or firewall. So even if you have two firewalls, that's a problem because we only have one handoff. So some providers might give you a second link. They might charge you more money for it. So that's an option you can explore with them. The second option, which is very common and what I'm going to do in this demonstration, is to use a WAN breakout switch. So essentially we have a switch that sits between the ISP handoff routers and the firewall, and that's going to allow us to extend the WAN connection to both FortiGates. So in this example, we'll have two internet service providers. So if you have two or more ISP circuits, that breakout switch will allow you to essentially define your ISP public subnets as a VLAN so that both firewalls can access each ISP properly. So really the takeaway is that the HA is not just about clustering two firewalls together. You also want to make sure that you have physical WAN topology that supports this failover, because if both firewalls can't reach those ISP links, then the HA design is essentially incomplete, right? You don't want to run into a situation where there's a failover and you have to physically move cables. And that's what this switch here will help us solve. So for the lab environment, we're going to be using a pair of 91G FortiGates for our HA pair. And then for our LAN side MCLAG, we're going to have two 248E switches. And then as my internet breakout switch, I'm going to use a 108F. You do not need to use a FortiSwitch for this part, right? This can really be any switch, or you can use two ports on your ISP handoff if you have it as an option. This is just the way I'm going to do it. So I figured I would put it in here. So I'm going to minimize this and I'm going to hop over to this whiteboard here. I kind of diagrammed out how the final topology will look, right? So let me see if I can zoom in a bit here. There we go. So we can see here I have two ISPs. I have ISP1, ISP2. I have the networking information here, and I have the VLANs that I created for them. So my ISP1 connects to my port 7 of my FortiSwitch, and my ISP2 connects to my port 8 of the FortiSwitch. And then I have port 1 and 2 going to port 3 of my FortiGate over a FortiLink, right? So both of those VLANs, so both of my ISPs, can go across my FortiLink to each firewall. So each firewall will have access to both WAN connections. We're then going to use port A and B on the FortiGate for the HA connections. You can really use whatever ports you want, like depending on the model of FortiGate you have, it might have dedicated HA ports. You can really use whatever you want as long as it doesn't have any references. You can really assign whatever port you want. So just for this one, I'll be using port A and B. So that'll be my HA connections. And then what we have is our MCLAG connections. So what I have is we're going to have X1 of Firewall A going to port 47 of Switch A, and then X2 of Firewall A to 47 of Switch B, and then X1 of Firewall B to port 48 of Switch A, and X2 to 48 of Switch B. So basically, Firewall 1 is going to port 47 on both, and Firewall B is going to port 48 on both. And then we need our core switches to actually connect to each other. So for the MCLAG connection between switches, we'll be using port 45 and 46 between each switch. So that is the full cabling diagram. What we'll do now is I'm going to hop over to the firewall and I'll show you how I already configured the internet breakout switch, just in case you were curious. And then we'll build out the HA, we'll build out the MCLAG, and then we'll do some testing and some important commands to know and tips and things like that. So let's hop over there and get started. So before we get into the actual HA and MCLAG config, I just kind of want to show you what I have here. Before this video, I did the WAN breakout config. So if you were interested to see what that looks like, I'm just going to show you real quick. So this is just on my standalone Firewall A. I have not configured HA yet. We'll get to that. But basically what I did was, so this is the Fortilink I'm going to use for my MCLAG. And this is the other Fortilink I have for my WAN breakout switch. So that's on my port 3, right? So if I expand this, we can see I have my WAN 1 VLAN and I have my WAN 2 VLAN. And if we go to my FortiSwitches, we can see that I have my port 1 of the switch, or connecting to my FortiGate here on port 3. And then you can see I have port 7 and 8 on those WAN connections. All right, so my ISP1 connects to port 7 and my ISP2 connects to port 8. I have my VLAN and my IP address information defined, and then port 1 of the switch is connecting to this FortiGate here on the firewall primary. Then what I did was I just combined those into a SD-WAN zone. So I made this SD-WAN zone called SD-WAN Internet, and I put in both of the members in this bundle so I can use them both. And then I just created a static route that's just pointing, my default route to that SD-WAN bundle here. So that's really as simple as it is. So now that that's covered, we can get into the HA configurations on both firewalls. And then once that's done, we'll move on to the MCLAG config. All right, so we're back on the FortiGate now, and now we can actually get into the HA config. So here I am connected to what will be the primary FortiGate. So what I'd like to do first is just set a host name, just so when we actually have the cluster up and we're going back and forth between the two firewalls, we can just easily identify which one is the primary. So you can name it really whatever you want. I just do like A, B, C, D, whatever, right? Starting like that. You can name it primary, secondary, or whatever other naming convention you seem fit. This is just what I have here. So I have my primary host name as 91GA. So, right. So here we're on the primary, and what we're going to do is go to System HA. You can see, by the way, before I go over there, you can see I already have my interfaces selected, right? So when we went here on the diagram, we see that we're going to use A and B as our Harpy connections. And I already have those connected to each other. So what we're going to do is go to System HA, and you'll see here we have this drop down. We're going to do an active passive cluster here. So we can do the config right now. So we're setting the mode as active passive. Device priority. So this is going to impact the selection method, right? So we talked about how the device with the higher priority is more likely to become the primary. So just for this demo, we're going to set this as 200. This right here is a new GUI setting in 7.6. In previous versions, this is a CLI only setting. This is the set override enable setting. So you can actually do it from the GUI in this version. So since we are going to always want this one to be primary if it meets the monitored interface requirement, we're going to turn this on for now. So that will set override enable on this unit. And now we can actually get into the cluster settings. So what we're going to do is, I'm just going to bring up a notepad so I can write this down when I enter the password. So we're going to set a group ID, right? So we can set our group ID here. And this is actually how the virtual MAC addresses in the HA cluster are going to be created, right? So it's going to depend on what value you put here. So I'm not going to keep this as 0. I'm just going to set this to 1. And we'll have to match this on both sides. So we'll set that to 1. And then we'll set a group name. So we can really name this whatever we want, but for this case, I'm just going to name this HA-FortiGate _ lab. I'm just going to copy that over to the side. And then password, we're going to change this password, right? You can really name this whatever you want, or set this password whatever you want. So I'll just set one here. Like that. We're going to enable session pickup. We want the sessions to sync across the firewalls in our cluster. We're going to not set any monitor interfaces for now, just because we don't have everything cabled up yet with our switches and stuff. And I don't want to start failing over if we end up unplugging or reconnecting switches, right? So we'll come back to that. But these are going to be the interfaces essentially where if the FortiGate detects that one of those is down, then it's going to fail over to the unit that has the most monitor interfaces that are up. And for our heartbeat interfaces, we're going to set ports A and B. And for the priority, we're going to set the first one as a higher priority. So we can set this one to 250, and we can keep B as 0. And you see this backup heartbeat interfaces. We're not going to set one here for now. This is essentially a new feature to help prevent a split brain scenario. You might run into a situation where the secondary FortiGate does not hear a heartbeat reply from the primary, and it gets elected to primary, and now you have 2 firewalls that think they're primary in the network, and you're going to have a split brain scenario, and it's going to cause latency and connection problems. So that is something we can set, but for now we are not going to set that. And then for management interface reservation, this is how we can essentially set out of band management interfaces on both members of the cluster, and that's going to allow us to actually reach both FortiGates independently, no matter which one is the primary, which one are the secondaries. Because by default, when we have an HA cluster, the second one, since it's in a standby mode, it doesn't respond to traffic. So you won't be able to access the second one directly. You'll have to CLI to it from the primary. This is also useful if you wanted to do like independent SNMP monitoring on the other members of the cluster. So we'll set this later because it requires us to make some interface changes. So for now, we'll just keep this as default. And these settings look good, so we will just apply that here. And sometimes it takes a sec to complete because it's looking for the other member in the cluster, but once it realizes that there's no one there, it will resume access to our management interface. So we'll just wait here, and we see that that's configured now. So we see that we just have this one FortiGate in our cluster, and we can see now that these interfaces A and B now have like this little heart symbol, and these are dedicated as a heartbeat interface for HA. So that's the primary. What I'm going to do now is hop over to the secondary unit, and we'll configure the HA on that. Now we're on what's going to be the secondary FortiGate. So what I like to do really just to get started is just set the host name. So we have here 91 GB. This is going to be our secondary, and then everything else you can really just keep default. All the config is going to sync over from the primary once we configure the HA. So like all our other interfaces, anything else we might have configured on the primary, like policies and objects and users and routing, firewall policies, admins, system settings, all that stuff will be copied over. So we don't really have to worry about that. But we do have to set our host name since that's one of the things that isn't synced. So each firewall has its own config for the individual host name. So what we'll do here is we're going to go to the high availability config And we're going to set this to active passive, and now we can do our config items. So on the other FortiGate, we set that as 200. We'll set this one as 100. We want it to be lower, and we are not going to enable override. We'll keep override disabled for this one. The group ID, we're going to set to 1. The group name was HA FortiGate Lab. And we'll set our password that we set on the primary unit. We'll enable session pickup. We'll leave monitor blank and backup heartbeat blank for now. And then for the heartbeat interfaces, we will select ports A and B. And we'll set the priority again on interface A to 250 and B as 0. And that's it. This is really all you need to get started with an HA cluster. Of course, we'll get into some of the more advanced features and troubleshooting and all that, but for now, we're just getting the cluster established. So what we'll do is we'll hit OK here. And now the synchronization is going to begin. So I'm going to move my PC connection back to the primary. So I just changed my interface on my PC to the other firewall. And we'll wait for this one to come up. And there it is. And we can see our cluster should be established now. So if we go to HA, we can see we have the secondary unit here. And we can see it's not synchronized. So it's going to, when you do a initial HA setup, depending on how much config you had on the primary device, it might take a few minutes for this to sync, right? So if we hover over this, it'll actually tell us the tables that are out of sync, so we can see these checksums aren't matching for these specific interface items. So if we just wait a bit, we can see if this resolves by itself. There are commands we can run, which we'll get into later in the video, where we can actually force synchronizations, we can recalculate checksums, all this sort of thing. But I don't like to do that on the initial synchronization. I just like to wait a bit, sometimes up to like 10 minutes or so, just to let this do it on its own at first. So I will stop the recording here and wait until this is synced. All right, instead of waiting, I actually thought this would be a good opportunity, since we have it out of sync right now, just to show some commands we can do. So, right, like I said, you can kind of just hover over this and see. So we can see it is syncing, right? So before it was like 11 or so, and now it's 8. So it does take a bit of time on that initial config synchronization, right when we establish the cluster. So if I do a get sys HA status, I can see the details of my cluster. I can see the uptime. I can see what is the primary and why it's selected. So we can see that this FortiGate is selected primary because the override value is greater. We can see the serial numbers, we can see the checksums, and we can see that it's saying out of sync here, and it has the checksum. We can see some device hardware statistics, system resource statistics here. We can see our interfaces and the speed they're negotiating at, and the port counters and all that stuff. And we can see the index, and we can see actually this is the we can see the IP address over the HA link of the secondary. So we'll connect to the secondary in a bit here too. So that's a good command. What we can actually do is check the checksum. So we do a diagnosis HA checksum cluster. We can see the checksums. So we can see that some of them are out of sync, right? Like this root one here. So we got DCC6, E938. And we can actually start or recalculate the checksum with this command. So recalculate. So that's a good command to run. Usually you would run that on both firewalls just to recalculate the checksum. Sometimes just one of the tables is just the checksum is off, and you just have to recalculate it to get it started. We can actually force a sync in the CLI, so we can do an execute HA synchronization start, and this will initiate a synchronization with the secondary units. That's right. We're starting a sync. And what we'll do is actually go into the secondary unit. I'll show you that. So we can do execute HA manage, and we can see the index was 1, right? So this index here for the secondary unit, 1 admin. And here we can actually CLI into the secondary unit. So we can recalculate the checksum here. So we can do a diagnosis HA checksum, recalculate, and then we can do a execute HA synchronize start. All right, so we're going to give that a couple minutes. So I will come back once that sync is finished. Okay, so I gave it some time and the HA is finally synced. I ended up rebooting the secondary, but it still was out of sync on a couple of the tables once it came back up. So I waited about 5 minutes and it finally synced. So when you're setting up HA for the first time, like I said, don't be alarmed if it takes a little bit of time. It's syncing an entire config file worth of data to the other device and writing it to memory on the other unit. So you just have to give it some time. So, you know, ideally you'd be doing this out of production anyway when you're getting the cluster spun up. So once you get it spun up, just give it some time to sync before moving on. So you can see here that the cluster is fully in sync. I got my primary, my secondary. If I click the secondary here, I can actually see the interfaces on each one, which is actually really nice. So what we're going to do now is get our switches connected. So I have my switches here, my two 248E FortiSwitches. I have them powered up, but I don't have them connected yet. So if we just hop back over here to our diagram, you can see I'm going to cable these now. I'm just going to walk over to my desk and do it. So what we'll do is Firewall A will connect to port 47 on both switch, and then Firewall B will connect to port 48 on both switch. So what I'm going to do actually before I connect them is, so this is the FortiLink that I'm going to use for my LAN switches. So you can see I have my two interfaces as members. I have it dedicated to FortiSwitch, and what I did was I disabled FortiLink split interface. This is something you would use if you had like a ring topology, for example. Maybe you had like a ring of 5 switches and you had the first FortiSwitch connected to your FortiGate and the last switch connected to the FortiGate. You only want one of those links to be active at any given time. So you would turn this off so the FortiGate knows which link to actually turn off, and then it would turn it on if it detects that there's a down link. But since we're using MCLAG, we want both of the links to be up. So we're going to keep this disabled, and I'm just going to turn this setting on here, automatically authorized devices, just for the purpose of this maintenance window, just so I don't have to manually authorize them. So as soon as the FortiGate detects, it's going to say, hey, I see a FortiSwitch, I'll authorize that and bring that into my config. And that is it. So what I'm going to do is I'm going to cable this up like this, and then we'll wait for it to authorize on the FortiGate, and then we'll configure a couple VLANs just for testing, and we'll need VLANs too for when we do the HA management interface. And then once we get them up, I'll show you how to do MCLAG. So I'm going to walk over here and do the cabling now, so I'll come back once that is all done. All right, so I went ahead and I made those connections that you see here. And you can see we connected each FortiGate to each switch. And before I was showing you that change I made with this split link interface. So you can see now if I go to my switches, one of them is down, but I can still change on this. The reason why it's showing down in FortiLink is because this is essentially not a valid topology since we haven't actually enabled MCLAG yet. So you might see one of them as down, but this is fine for now. So I have my two switches and we're actually going to configure MCLAG now. So what we have to do is go to FortiSwitch ports. And I'm going to use the little gear icon here. And you can see I have LLDP profile in my active columns. By default, you'll probably have it in your inactive columns. So feel free just to move it over. And what you'll see is by default, every switch on a FortiSwitch comes with this default LLDP profile. And this is essentially looking for other switches or a FortiGate. But what we want to do is change this. So we are going to do MCLAG between the two switches on ports 45 and 46. So on ports 45 and 46 of each device, we are going to change the LLDP profile to this one, default auto MCLAG. So we'll change this one, and we'll change it on this port as well. And then we'll scroll down to ports 45 and 46 on this switch. So 45 and 46. So now what we'll do is connect both. Okay, I'm back. So I just connected those ports. So you can see the interfaces are coming up. So we'll give this a bit. So you can see these ports are now active. Let's check the second one. They're both active. And they can see the switch on the far side. So now what we should see, if we go to Topology, switches, and if we create this MCLAG pair, let this think. So we can see both our switches are up now. So can we ping both of them? We can. If we look at our ports again, we can see the switch is detected. So now if we go back to our topology, let's try to create the pair on the other ports. Okay, so it says it might take a minute to show. All right, so it says it might take a couple minutes, so I'll stop the recording. I'll wait a few minutes, and then I'll resume once the topology updates. All right, we're back. So I let the switch do its thing for about 5 to 10 minutes, and it actually connected. So just to kind of recap what we did is that we, on our FortiSwitch port config, we went to the ports that we're actually going to connect the two switches to each other on. So that's 45 and 46 on both, and we assigned the MCLAG LLDP profile to all 4 of those ports. And then what we did was we go to our managed FortiSwitch in the topology, and it will then, after you wait a couple minutes, it will detect that there's a connection there. And then you'll be able to click that connection and do create an MCLAG peer. And once it thinks for about 10-15 seconds, you just have to wait like 5 to 10 minutes for the switches just to negotiate the MCLAG together and to establish that connectivity. So just give it some time. And then once you refresh this a few times, you should see this. So we can see here, we see our 2 FortiSwitches in an MCLAG peer. We can see that they are connected to the FortiGate on 47 and 48, and then 45 and 46 are the MCLAG peer, right? So if I hover over that, we can see like that blue light link show here. So like this blue link is indicating the MCLAG. So if we hover over here, we can see 45 is connected to 45 and 46 is connected to 46, all in a forwarding state with MCLAG enabled, and that link is up and working. So at this point, we have established a HA pair of FortiGate firewalls in an active passive configuration. We then deployed 2 248E switches in an MCLAG peer, and each switch is connected to each member of the FortiGate cluster. So right now we have firewall redundancy and switch redundancy in our core. So that's essentially it for the config, right? So at this point, you'd pretty much be ready to go for full redundancy in the network. But what we'll do now is just kind of review some other tips and tricks and just go over some troubleshooting and CLI commands that are useful for this sort of thing. All right, what I did is I just off camera, I just created a couple VLANs just so we can do the next part. So I created a production VLAN for my PC and I created a lab VLAN, and this will essentially be my management network. So you can see that I'm accessing the firewall now on this IP address. I have that production VLAN on port 1 of the first switch, and I'm connected to that, and I have a firewall policy that allows me to get to that lab VLAN IP from my production network. Right, so that's how I'm accessing the firewall now. So what we'll do now is we'll configure HA management reservation interfaces, which will allow us to access both units in the HA cluster. Because remember before, we showed how you can only access by default the secondary unit via CLI only, since it's in standby mode, it won't respond. So if I do I'll show you how to do that quick. If we do a get system HA status, we can see that the index of my primary is 0 and the index of my secondary is 1. So I can do execute HA manage 1 and then the username. So I can sign in to I can access the second one that way. But what if we wanted to be able to access both via the GUI or via SSH, or if we wanted to do like SNMP monitoring on both units and not just relying on the first one? We need to create HA management reserve interfaces, which is essentially just creating an out-of-band management port for each firewall. So if I go to my HA settings here, we can see that here is where that is set. So this is on the primary one. So what I can do here is enable this. And we have to define an interface. So for the purposes of this example, we will use, what port do we want to use? We can do port 6. And then we'll have to set a gateway. So we want to use that IP address of the lab VLAN we just made, since that's essentially our management VLAN in this case. So I can set that like this. Then what I'll do is go to my interfaces, port 6, which is our new management. I will label this management. We'll set this to manual, and we can set an address within that subnet. So 10.4.95, we will do .21. And we can enable our management administrative access ports. What I'll do is I'm going to set a secondary IP too. So for the secondary, we can do .20. And we'll enable those same services. Disable HTTP. Like that. All right, so now what we'll do on the secondary, right? So I have the secondary CLI up here. Do config system HA show. So we can do config HA management interfaces. We can edit one, and then we can do set gateway to that same gateway IP. And then let's just make sure there's nothing else. If we hop back in here. All right, so if we edit this guy in the CLI. Set interface port 6. Like that. And we can do end, and then we can do show system HA. And there is our config. So we see on both, this is the same, right? Secondary, primary. And then we can do is go back into, I want to go back into the primary, into the secondary. Like so. We can do config sys interface. We can do edit port 6. We can do set IP 10.4.95. This one can be .22 /24. Oh. Get set mode static. It was set to DHCP, so now we can set that, right? And we can do a set allow access. We can do HTTPS, SSH, ping, SNMP. And then if we do a show system interface, we can see our port 6 interface. So now what we'll do, so we can actually test this, is go to our switch ports. And for this example, we can just use port 2 on this switch. So we can assign this to the lab VLAN. Like that. And then what I'll do is grab a cable here. And I'll connect port 6 Okay, so I just connected those ports. And now what I should be able to do is access both. So let me just create 2 tabs here. And sign in. All right, so now I can access, as you can see, I can access the primary and the secondary now individually of each other. So this is very useful. So that's going to be it for this video. Just to recap what we did, we reviewed HA and MCLAG, what they mean, what you get out of it, how to configure an HA pair with 2 FortiGate firewalls in an active passive cluster, and then how to connect 2 switches MCLAG to that HA pair. We did some commands and troubleshooting, and then we also did HA management reservation interfaces to define out-of-band management on every firewall in the cluster. So that'll be it. If you have any questions, feel free to leave a comment, and thanks for watching.